Hello everyone, it's Zenit20 and in this video, we'll be creating a snake game using HTML, CSS and JavaScript. So let's get started. First of all, we're going to have a basic HTML structure, nothing special in that. We have the link for our CSS and the script, which will be deferring it. We'll be pointing to the index.css and index.js, and we will only have one single div with a class of board, which is going to be the canvas for our game. So let's straight away move into the index.css. First of all, we're going to give the style for our board. Or let's give the style first of all for our body. And for the body, we're going to give it a display of flex, align items center, and justify content center. And we're going to give it a height of 100 view height. Next, in the board, we are going to give it a height of 90 view min, and the same thing for the width. So we're going to give it a minimum viewport width and height. Next, we are going to create the grid for our game. Let's give it a background so that we can see what exactly is on web page right now. So if we run up our website, we can see that we have a square over here, nothing special. We can open the console side by side to see. So we have our square over here, a very bland square. Next, let us split this into a grid, because our snake will be based off this grid, and this grid will have some columns. Let us make 30 columns, and we're going to give one fraction of it to every column. We're going to do the same thing with the grid template rows, same 30 columns. Now if we see, we have our grid over here of 30 by 30. So now let's give the basic styles for our snake. So a basic snake tile will have the background. In fact, we don't have a background. We'll manage that in some way. It will have a border. It will have a border of 1 pixel solid black or 12 hashtag 121212. That's for the snake. And we can copy this now for the food tile. I'm referring to them as tiles over here because they will be represented on the grid individually. Each of them are going to have their own information. So the food will have the same border, except that we'll give it a background of red. And really, that's it for the styling. Let's now move on to the index.js. In the index.js, we are going to write certain functions, which I've listed over here. We first of all are going to write the function for drawing the snake, and then we'll also write the function for checking all of the collisions. Then we'll write the function for updating the snake and its positions each and every time it moves. And then we'll also give a function for restarting the game in case if the player hits the edges or if the player hits the snake itself, which are the cases for losing the game. And then we're going to give the function for DrawFood so that we can randomly draw food on the board. We're also going to write the function which will manage extending the snake. And this ChangeDirection over here will be our event handler for taking the inputs, and GetDirection will store the direction in which the snake is moving. So let's start. First of all, I'm going to declare a constant of board, and I'm going to give it a document dot query selector of dot board. That's our board. Next, I'm going to declare a direction, which is going to be an object that will hold two properties, x0 and y0. Next, I'm going to declare an array named as snake body. The snake body will be an array of positions. The first position will be x1 and y1. Y1 because the CSS grid starts from the first column and first row and ends at the corresponding column and row. So if you're going to place 0 over here, we're going to then stumble upon some issues with the collisions. So make sure the first part of the snake body is going to have the coordinates of 1, 1. All right. Then we're going to store another variable and we're going to name it last direction. That will be used in checking some collision conditions. And that's it. Let us start with the first function of DrawSnake. In fact, let us leave aside the function and let us first of all start the game loop. How exactly will our game loop look like? So our game loop will be basically a set interval, and it will have an interval of around 500 milliseconds. You can change this accordingly, and this will change the speed of the snake as well. And in this, we're going to give three functions. The first function will be the DrawSnake, second will be the CheckCollisions, and the third will be update. So we'll first of all draw the snake, then we'll check the collisions, and then we'll update it. Make sure this is the order, otherwise we'll again stumble into some errors. So we'll enable the function DrawSnake, and we're going to write the function. So how exactly are we going to display our snake? So we can display our snake in this way that we can loop over the snake body dot for each segment. We are going to create a div or a part. Let part equals to document dot create element, and in that we are going to add a div, and then we can add, after that creating the div, then we can style the div. So the part, it will have first of all class list. We're going to add the class list snake so that we can mention that it's a snake tile. Then we are going to give it the coordinates. Yes, then we are going to give it the coordinates. So we're going to say part. For that segment, we're going to give the part dot column start, grid column start, in fact, the style. Yes, in the style column, grid column start, and that will be according to the segment dot y, and the grid row start will be segment dot x. So the grid corresponds to the positions. The last thing which we're going to do is that we're going to append it to our board dot append child part. Let's also give it a background color, part dot style dot background. We'll give it cyan for now. Let us see. CheckCollisions is not defined. We're getting that error, but we have got our snake piece over here. All right. Let us now make the update function. So let's just hypothetically give our snake two parts. So we'll push this one to the front, and we're going to keep this behind. Now we have two of the snake parts. Okay, maybe this is swapped. We need to change the segment X and segment Y. Yes, that's the correct way, because the first piece was supposed to be on the second X. So make sure for the grid column start, we're going to have the X coordinate, and for the grid row start, we're going to have the Y coordinate. All right. Next, let us make the update function, or let's make the change direction function. So let's make the change direction function. We're going to add an event listener of key down, and in that we are going to pass in the change direction function, which I'll just create over here. First of all, function change direction, and we're going to pass it into our event listener. All right, we're going to give the parameter of event or change direction, and now we're going to listen for the change in the direction. So we're going to create our key as event.key, and we're going to use a switch statement. So we are going to switch over the key. First of all, we're going to check the value for arrow up. If arrow is up, then direction is equals to x is going to be 0 because we're going to move in the upwards direction, and y is going to be -1. According to the grid, -1 means that we'll be moving upwards and +1 means we're going to be moving downwards. We're going to now copy this, arrow up. Same thing we're going to do for arrow down, arrow right, and arrow left. For arrow down, it's going to be +1, and for arrow right and left, there will be no component for the y coordinate. There will be values for the x coordinate. So for arrow right will be +1 and arrow left will be -1. That's it. That's the direction set. Next, we're going to make the GetDirection. The GetDirection function will basically get the current direction because we want the direction to be given to the update function when it asks for it. Otherwise, there might be some overlapping errors where the user clicks the buttons of the arrows too quickly and the snake will start overlapping itself. So in the GetDirection, we can manage that by making last direction is equals to direction, and we're going to return the current direction so that we can store at least the current last direction. Okay. Now we're going to make the update function now that we have all the components. In the update function, we're going to have a for loop, and we want to shift all of the elements of the snake to the position which they're moving. So let me write first of all, let I is equals to snake body dot length -1. I is greater than or equals to 0, and I minus minus. All right, there's a typo here. That's our for loop. And what we're going to do is over here, we're going to take the snake body, I +1. The next one, we're going to take it, and we're going to give it the coordinates of snake body, I, and we're going to spread it inside an object. Then we will assign those. Basically, what this for loop does is that it goes over the snake body array where it's starting from the second last element. So in this case, the second last element is this. So whenever the snake moves, what it does is that it takes these coordinates and it shifts it downwards in the array. And then the new coordinate which is given is placed upwards. And then the loop again repeats, and then the new coordinate which is passed in the first object or in the first head is then passed downwards. We can then make this increased. We can then change this by adding the we can then change it by adding the snake body I, and we can change it according to that. So we're going to change the snake body 0. Why 0? I'll tell in a minute. Snake body dot x is equals to, we're going to increase in it direction dot x. We'll then copy it. And we're going to do the same thing for the y component. For now, let's not check for the CheckCollisions and let us see if our game is even working at all or not. If I'll click this, we can see our snake is going diagonally. Let us see what's happening over here. All right, I can see what's the problem here. We forgot to change the y to 0 in this case. Now, if we try it, you can see our snake is moving, but then there's this problem that the canvas is forgetting to erase the previous copies of the snake. That can be easily done by going into the DrawSnake function, and we'll change the board dot inner HTML, or in fact, we'll do it in this way. We'll in fact take the board dot children We'll take board.children and we're going to place it inside brackets. We're going to basically make an array out of this collection. And for each of these tile, each of these will be referred to as a tile. We're going to check if tile.classlist.includes, if it contains, if the tile.class list contains the snake class list, so we will remove that tile. We are doing it in this way selectively because we will also be drawing the food on the board. So suppose if we add board.inner HTML over here, if we add the board.inner HTML over here in the DrawSnake, the entire board will be erased along with the food which is drawn on the board, potentially ruining the game. So now if we go back over here and we'll press the right key, so we can see we're still getting an error. Maybe this was -2. All right, here's our snake working. We got the problem fixed. So what the problem here was that in the update functions, we had to check the second last element. We were not getting the second last element. We were actually accessing the last element by putting -1. We had to access the second last element. So that was the problem. Now we have our square over here. If I press, suppose, the down arrow key, it will move down. If I press the left arrow key, it will move left. Up arrow key, it will move up, and so on. But it's doing it with a bit of delay. So we can do it by using GetDirection. And in fact, not in the GetDirection, we'll use the update. And we're going to use let dir is equals to GetDirection so that we can instantly get the direction because there is slightly jittering in the direction. We don't want that jittering to happen. So now if I will turn, so now it's a bit faster. All right. In the index.css, I'll just add overflow of hidden so that at least we won't have any scrolling. That's much better. All right. That's done. We can now remove this first part of the snake and we can return it back to 1, 1. That's done and that's also done. Let's go for making the food. So the DrawFood function will work in this way. It's a really easy function. It's almost the same as the DrawSnake function, except that we're going to do two different things. First of all, going to create a random X coordinate. We're going to use math.floor to round the value, math.floor. Then we're going to use math.random. And we are going to multiply with 30 minus 1. Or in fact, we're just going to multiply it with around 30 so that it can remain inside the container. Let rand x equals to math.floor, math.random. We're going to do the same thing with the random y coordinate. We're basically making the random position and we're going to multiply it with 30 because our math.random could return 0 or 1. We accordingly multiply it with 30. All right. That's the two random coordinates made. And then what we're going to do is that we're going to copy the code from snake body from the DrawSnake function. And we are going to add it over here, except that we're going to rename the part to food everywhere else. Food is equal to document.create element div. We're going to add the class list of food. We're going to give it a background. In fact, don't need to give the background, that's already in the class list. And this is going to be random x coordinate and random y coordinate for the position of the food. And we're going to append that child to the food. And we're going to call it over here, DrawFood, only once. We can see we got random position. If we refresh it, the food changes direction as we expect it to do. So it works how it should. One final thing which we should add over here, we're going to first of all check if random x is equals to 0. If it is, then we're going to return 1. Otherwise, we're going to return random x. Because as I had said previously, we cannot allow 0 to go over here. 0 does not work with CSS grid. The CSS grid's column or the row always starts with 1 rather than 0. So we make sure that if the random y or random x is returning 0, we're going to return 1 instead of 0. That's the DrawFood done. We're going to call DrawFood only once in the outside of the set interval because we don't want it to repeatedly appear. And the last thing which I'm going to do to complete this function is that I'm going to create a variable outside, which will be food data. The food data is going to store 3 things: the x coordinate, the y coordinate, and the element, which will be undefined for now. So in the DrawFood, we are going to set the food data. X is going to be random x, y is going to be random y, and element is going to be food. That's the food data as well created. All right. Now, before I go over collisions, I want to show one special behavior of the snake which we haven't yet fixed. If I'm going downwards, I can press the upward key and my snake will start moving upwards. Similarly, if I press the right key and then I press the left key, my snake will move backwards. The snake cannot move in the same direction which it was moving. Basically, if it's moving upwards, it cannot move downwards unless it turns. So we'll have to prevent that behavior from happening because that would mean that the snake would be overlapping its own body and that will obviously result in game over. So in the arrow up, we're going to check one condition. If our last direction, because we're going to check from the previous direction or from the current direction, if our last direction dot y is not equals to 0, it must be 0. Otherwise, it means that we are already moving in the y direction, either up or either down. So if we are saying that y coordinate will be 0, we mean that the snake must be moving either left or it must be moving either right in order to turn to the upward direction. So if the last direction dot y is not equals to 0, then we're going to break out of the case switch. Simple as that. Same case we're going to do that with the arrow down. And we're going to do with the arrow right, we're going to check last direction dot x. And that should do it. If we now go back to our game and try moving backwards, we can see that now I can't move backwards even though I'm pressing the backwards key. If I try moving downwards and I try pressing upwards, I cannot move upwards. So that is fixed. Now let's go on to the collision. All right. So we're going to enable the check collisions. The check collision will be checking for 3 main collisions. So let's create the check collisions function. So our check collision, first of all, must be able to check whether the snake is colliding with the food. That's the most primary thing which we have to check. So if snake body 0, make sure we're selecting 0 because 0 or the first value, the first coordinate of the snake is the actual head of the snake. So we're going to check if the snake.x is equals to food data.x and the y coordinate of the y coordinate of the snake and the food data is also the same. That means they both are overlapping. The food and the head of the snake is overlapping. And if they're overlapping, then we remove the food board dot remove child food data dot element, and we are going to call DrawFood again, and we're going to extend the snake, which we have not written yet. Let's enable it. It's over here. So we're going to then create another function of ExtendSnake, and we're going to call that ExtendSnake function in the CheckCollisions. So how will the ExtendSnake work? Though it sounds very difficult, it's actually very easy. What we're going to do basically is that we are going to add to the snake array. We're going to first of all create the new coordinates for the part. So we're going to write let coords equals to, it's going to be x and y. So the x component basically will be snake body, and in that we're going to access the last element. So snake body dot length -1. The last element, we're going to access the last snake body's part, and we're going to add into it the direction, the x direction. Now I'm going to wrap this inside math.absolute. Why math.absolute? Because we want to know the direction.x and we just want to get the value of 0 or 1. There is a possibility over here that our x coordinate can be -1 and that our y coordinate also can be -1. But we don't want that to happen. We want always the value of 1 or 0. So the math.absolute basically returns that if the direction.x is -1, it will return 1. If it will give 1, the value will still be 1. Then we are going to copy this into the y component, and we're going to change the x to y. And this should be the coordinates. And now we're going to push it into the snake body. Snake body dot push coordinate. And that should extend our snake. If we now try getting towards the snake, let's try making the snake fast for now. Let's go into the snake interval and change this to 100. That must be okay. If we try to hit the food, we can see that our body of the snake is extended. We'll touch it again, the body is extended, and we'll touch it again, the body is extended. And you can see how each of the part of the snake is moving one by one sequentially. Not the whole snake is moving all together. Again, our snake is extended. So it looks like our snake is extending perfectly. But still, the collision with the wall and not with the body of the snake is not complete. So if I'll try colliding into the own snake's body, it will not stop the game. Similarly, if I'll go out of the border, you can see our snake has appeared from the other side. And if I'll collide downwards, our snake simply disappears. So we don't want that to happen. That's the second case, which we'll be checking in the CheckCollisions. If we go over here now, in the CheckCollisions, DrawSnake, update, DrawFood, ExtendSnake, ChangeDirection, CheckCollisions over here. So that was the first part done. Now we're going to check for the collision with the border. So if snake body 0 dot x is equals to, or if it is greater than -1, in fact, if it is lesser than 0, or snake body 0 or the head, its x component is greater than 30. Why 30 over here? Because we already set in the index.css that our grid will be having 30 boxes. So if it is bigger than that, then we're going to restart the game. Over here, restart function. Let me just make the restart game function. So we'll call restart game. And we're going to also alert the player of game over. Game over. And we're going to call restart game. Now, if the snake is not going out of the board in the x coordinate, we can check for the y coordinate if it's going out of the board in the y coordinate. So else if the snake body dot x, we just change the x with y and that's it. and we'll call game over, restart game. That's it. In the restart game, we are going to now change how the game will work by shifting the game back to its original coordinates from where the snake was and changing the size back to the default value. So all we have to do now is go in the restart game and we will add snake body is equals to a new array in which we will set it back the coordinates to x1, y1. And we are also going to change the direction or the direction in which the snake will be going back to 0 and 0. So that the snake does not just start moving as soon as the game restarts. These should be the last two components. Yes, that should be it. So if I'll now try colliding into the border, it says game over, it restarts back. I'll collide again, it will say game over. If I'll collide upwards, it will say game over. Let's collect some food. And let us see if we can collide again. So if we cloud downwards, so if we try colliding downwards again, it gives us game over and it restarts it. Perfect. Those were the second condition done. Now for the third condition, where the snake collides with its own body. That again is very easy. If we go into CheckCollisions, all we have to do is snake body dot for each segment I, we're going to check if snake body I dot x is equals to snake body 0 dot x. Basically, we're checking if the current component of the snake is touching the snake body 0. Snake body 0 will be always referred to as the head. So if that snake body x is touching the x component of the head, that means it's overlapping. But we also want to check if the y is overlapping. So we're going to do and we're also going to check if the x is same. Make sure this is a double equal sign for checking equality. And one thing, that I is greater than 1. Make sure I is greater than 1, otherwise it will give an error on the first part of the head. As soon as you touch the food, it will give us an error because it's the first part of the snake which will be added to the back of the snake's head. We don't want the own snake's head to give the collision. We want it to collide with other parts of the body, not its own head. So if that's the case, that they're both overlapping, we again give game over and we restart the game. So let's try building up a long snake. Game over. What seems to be the problem? It's given us a game over quickly. All right, segment. Let's just go with segment dot x and segment dot y is equals to segment 0 and xy. Now let's check it again. All right, it's fixed. We had to use segment, not the actual snake body. We had to use the segment given to us by the for loop. For each loop, you can see it's perfectly working as normal. We won't collide with the border. We want to see if it is going to hit it to its own body. Okay, our snake is almost big so that we can collide into its own body and we can. It's difficult. And there we go. The snake's head was right over here and it collided with its own body. It was a game over. That's it. Now, one last thing we can add to our game to make it really shine out is that, remember that I had made the part.style.background to cyan. Well, let's change the cyan and let's give it a HSL value in which we are going to give we're going to have, in fact, let's put it in backticks. We're going to make a string literal of HSL. We're going to pass into it I multiply with 20 plus 20 so that we can change the hue, whereas the saturation will remain 50 And let's keep the lightness around 50. Let's make the saturation around 60. And let's experiment with the colors a little bit. All right, it gave us this dark blue color. Okay. Yes, it seems to work fine. But instead of starting from the blue, why don't we start a bit more backwards? Maybe from 10. Okay. Okay, it seems to say game over when we collide by sideways. Should not be like that. Okay, that was not a bug. Okay, our snake is working fine and we're also getting these colors. But let's change the colors to be, let's make it RGB 10 plus. We can make I multiply by 20 plus 10 so that we can have a base color. Let's try that again. That's too dark. Let's go for 20. Almost there. Let's make it 50. Yeah, that seems to be fine. Okay. You can see it's giving us a nice gradient for our snake. That's perfect. So this was a snake game that we had created. I hope you had enjoyed this video, and I'll see you in the next one.